Okay, hey, hello, hi, it's your girl Zoe again, and we're going to be looking at relative atomic and relative molecular mass. Can't wait. So, relative atomic mass, or AR, is the average mass of an element compared to 1/12 the mass of a single carbon-12 atom. Okay, what does this mean? Also a great place to start. So 1 AMU is defined as 1/12 of the mass of a single carbon-12 atom. So AR, relative atomic mass, is the average mass of an element in units of AMU. Cool. Almost every element has multiple stable isotopes. This means that some atoms of an element will weigh more than others. The average mass is the average of the masses of the elements weighted according to their abundance. So for example, 35 Cl is 75% abundant and 37 Cl is 25% abundant. So the relative atomic mass is 0.75 times 35, in brackets, parentheses, plus 0.25 times by 37, also in parentheses, equals 35.5. Okay. So, relative atomic mass is measured relative to 1/12 the mass of a carbon-12 atom. It's measured in AMU, and it takes into account the natural abundance of isotopes. Relative molecular mass, MR, is the average mass of a molecule compared to 1/12 the mass of a single carbon-12 atom. 1 AMU is defined as, okay, we've done this. So, MR is the average mass of a molecule in the units of AMU. Everything's in AMU. AMU is Bay. Recall that the AR takes into account the differences in mass and abundance of isotopes, right? This means that we can simply add the AR values for all the atoms in the molecule to calculate the MR. Perfect. Good news, everyone. When calculating MR, you must add the AR values of the atom and the AR values of the atom. So, let's do a worked example. What is the MR of benzene? So, recall the molecular formula of benzene molecule, which is C6H6. Then, find the relative atomic mass values of the atoms in the molecule. So, the AR of C, carbon, is 12, and the AR of H, hydrogen, is 1. Then, we can calculate the relative molecular mass. So the MR is 6 times 12, in parentheses, plus 6 times 1 equals 78. Okay, relative atomic mass is the average because almost every element has multiple stable isotopes which are of different masses. Okay, that's all for today. Thank you so much for joining, and we'll see you on the next episode. Bye.